Okay, so I think we'll start. So thank you very much for your patience. I hope everybody's had time to log on. If you can just mute your mic, please, and disable your camera. So this is our second SpiroExpert web chat. The first web chat we did was in February, where we covered duration and degassing. During this session, we're going to cover the topic of VDI 2035 and how that is applicable to the UK markets. I'll just introduce myself if I can. My name is Tony Carling, and I'm the National Key Account Manager for Spirotech. And I'd like to introduce my colleague, Steve.
Hi, Steve Simmonds. I'm the Special Project Engineer. I get involved a lot in understanding failed systems, and the application of 2035 is quite relevant here.
Cheers, thanks, Steve. You do have the option to ask questions throughout the course of the session. If you can message your questions through the chat option, and we'll try and ask as many questions as we can during the course of the session, obviously time permitting. So if you're ready, Steve, I think we'll just dive straight into VDI 2035.
Okay, yep.
So I've got a list of frequently asked questions that we get asked about VDI 2035. So the main question is, number one is, what is VDI 2035?
Okay, it's a European standard for water quality in closed heating systems.
Okay.
Specifically closed and heating systems. They're the key words there.
Okay. So is this the European version of BS 7593?
Not really, no. I know a lot of people sort of equate the two because they're both about water quality, but they come at the problem from different ways, and they're actually very different. In really, is that VDI 2035 is about understanding the system and making the system better, whereas the British standard is more about, oh look, you've got a problem. How can we put chemical treatment onto that?
Okay.
Without addressing why it's all happening in the first place.
Okay. So what are the main issues addressed?
The two main problems that people would recognise would be scaling and corrosion.
Okay.
And then it looks at ways that how that happens, how it can be addressed.
Okay, so is it possible we could look at these separately in more detail?
Absolutely, yeah. First, let's look at scaling.
Okay.
Obviously, there's water hardness varies across the country, but it's always an issue. It can vary from country to country as well, and there are maps available for these, but they're not that accurate, and it's always better to take a sample specifically where you are,
okay,
so you know exactly what you're dealing with. If you bear with me, because I've had to make a lot of notes on this, and try to work out what's the homework. Yeah, exactly, yeah. So the scaling is it becomes more problematic with the hotter the system gets. If you just think about your kettle at home, that gets a lot of scale in it because it gets hot.
Okay.
So the heat, and obviously being a heating system, is what makes the deposit of the scale available. Mm-hmm. And obviously the higher the temperature, the more it's going to be affected. So the key area where line scale will be a problem is on your heat exchanger in your boiler. And that's the thing that's going to that's going to directly impact on the efficiency of the boiler and its ability to heat the water as fast as you need, and therefore the needs to run longer, which impacts on operational cost.
Okay. So based on that, then, how can scaling be prevented?
Well, you can either, there's two sort of methods. You can either just soften the water,
okay,
or you can desalinate or demineralize the water. The larger the system, then it becomes demineralization is probably the better option. On a smaller domestic system, just general softening will do a good enough job because it's a relatively small system. Mm-hmm. But as your systems are getting larger, more powerful, more critical, then that full demineralization is probably a better option.
Okay.
Either way, I mean, you're looking to get rid of the chlorides and so forth, magnesium, things like that. And that's normally done via ion exchange. Now, but whichever way you sort of approach these things, you're also going to affect. What was it? The conductivity. Yeah.
You made that many notes.
Yeah, that many notes. I'm getting lost in it. Yeah. So that affects the conductivity of the water as well.
Okay.
Yeah.
And what about corrosion, Steve?
Primary factors causing corrosion or being able to measure it is the corrosion cause is probably oxygen is the major factor, and the way you can sort of understand that is via the pH value.
Okay.
But let's say other things that cause it are chlorides, microbiology, organisms, although they are relatively low key compared to, say, oxygen is the main thing. However, as you move towards lower temperature systems, the microbiological factors will become more important, because at the moment the temperatures we run at tend to sort of really kill off the microbiology. As we're getting the temperatures lower, they're going to become less impacted by that, and therefore become more of a problem. But as your temperature drop, your scaling is going to drop off the problem. So there's always something else to give you something else to worry about as you change another thing to solve one problem.
Okay. VDI references the appearance of the water, the conductivity and the pH value to monitor corrosion. Why these? And is that all?
No, there's other ways to monitor what's going on in the system. You can do many chemical checks and so forth. But those three particular items are very simple to measure, and will give you a sort of a pretty quick snapshot of, I can see what's going on.
Okay.
So they're the three things that are really focused on as the easy things to give you indications of how to start thinking about the system problems. Now, I think in the VDI that those items have specific values and ranges. You go, if I'm between this range, this is problematic, or this is where I need to be and I'm outside it, up or down, I need to get into it, and then how to get into it. And I think the British standard is very much talk to a third party about it. Ask someone who should know better about that. They would be may have a vested interest and would use it as an excuse to sell chemicals.
Okay. So what does the pH value tell me about the quality of the water?
Right, so pH is a very basic parameter, and we should, I know I learned it in school, I'm sure they still teach it.
Yeah, they do, yeah.
Fingers crossed. So water, you have a scale of 1 to 13. 1 is pure acid, 13 is pure alkali, and 7 in the middle is what we call neutral pH. And it's generally sort of where you have your drinking water supplies around 7. What you have to look out for is certain materials have certain reactions at certain pH levels, and because we use so many different materials in systems, there's not one ideal position or one ideal value, so you have to work with a range. And it's a matter of getting the range to suit all the materials you've got.
Okay.
So for instance, you have ferrous materials, or something like this, iron, stroke steel. It will tend to grow if the pH value is below 8. And if it's higher, they will obviously be less susceptible. Conversely, aluminium materials, which is probably what's used in the heat exchangers, don't like a pH value above 9. So you have to meet the minimum of other things and not exceed the maximum of others. And so generally you need to look around about the over 8 and less than 9, and somewhere in the middle of that is generally great. You can never dial in an exact number and keep it there. It's very hard, because there's always processes going on that are going to affect it.
Okay.
Yeah.
So isn't the water we use to fill systems typically in the range of 7 to 8?
Indeed it is. So generally we use more or less tap water to fill a system, and that comes in 7 to 8 because, as humans, we don't like to drink acids or alkalis. Definitely not acids. Well, a bit of vinegar on your chips is not so bad. But also, when you once you add that water to the system, the pH value is going to change because of chemical reactions and so forth. And also, if you do subsequently treat the water, you're going to affect the pH value.
Okay.
And normally that would be downwards. However, as I mentioned, there's chemical reactions going on. The reaction of the oxygen and the ferrous materials will actually cause an increase in the pH value. So if you put in 7 to 8, then you are slowly going to get an increase in pH. It's called self-alkalization process.
No, right, okay.
So generally what you'll do is you fill the system up, you create the system, fill it up with water with 7 to 8 pH water, and then it will start to increase over a relatively short period of time because the oxygen reaction is quite quick. It will generally increase, and it happens to naturally sit in that range 8 to 9, really. But if it's not, you then may need to take action towards that.
Okay, thanks, Dave. As I said before, you do have the option to ask questions through the live chat, so I'll just give you another option, another moment. If you do have any questions, please message them through the live chat and we'll try to answer them towards the end of the session, obviously time permitting as well. So Steve, based on what you've just said there about pH values, is there any leeway in pH values? It
would depend purely on what materials you've got involved in your system.
Mm-hmm.
You've got quite an old boiler that's got, sort of a steel heat exchanger or something. You don't have to worry about going so high because you're not impacting the aluminium because it's not there.
Okay.
So you say it's very much you've got to look at what materials are involved, and it's not just you've got to look down to components of an item, not just that's that item. I mean, for instance, even in like an automatic air vent, there's several materials in that.
Mm-hmm.
You have to work out which are only going to be anything I need to be specifically aware of in terms of pH that are going to be affected in. Really, I can be at a lower level, or it's okay to go to a higher level, or so forth.
Yeah.
So it does take a little bit of homework. You might need to sort of know a bit more detail about your products and so forth. But again, it's the more you know about your system, the better you'll be able to look after it, or advise your customer how to look after it.
Of course.
There's a lot of it. Probably does involve a little bit of homework more than you probably expect to do. But say once you've learnt it, and then you'll say, I know all I need to know about these particular products.
Yeah.
You're then going to say, I'm going to go with these. I'm going to use these products, not those products, because I know about these ones. I can't get the information on those. This is the type of thing I'm going to focus on, and I can give really good advice to my customer. And they, word of mouth, hopefully, will then recommend you on a bit more work.
Yeah. Okay. Thanks, Dave. Thanks for that. Provided the system water is clear and without any solids. This is also one of the few real guideline values about the VDI that it stipulates. Maybe we can still briefly explain what conclusions we can draw based on appearance alone.
Well, as I said, you normally fill a system with drinking water.
Okay.
And you have an expectation of what that will look like when you put it into a glass out of the tap.
You do.
So when you put it into the system, really, it shouldn't change that much. But normally when people drain a heating system, it comes out black.
Yeah.
Not itself a problem. That shows there has been some corrosion. It's iron oxides. But you'll get a certain amount, and then it shouldn't really progress. So if it starts to get dark, as long as it's not really thick and gloopy and dark, it's just normally what you can do is you can take a sample out into a jar, put it down, and within a couple of minutes, all the little iron filing parts, magnetite, will be sitting at the bottom. And the rest of the water should still be quite clear. Yeah. If it's not, or even worst case, you say that's created by oxygen. So if it comes out a bit black, but you let it settle and it's relatively clear, that's pretty good.
Okay.
But if it just stays black, then obviously you're starting to see you've got a lot of corrosion issues. If it comes out sort of red, rusty red, that basically means you're continually oxygenating and continually corroding, and it's getting worse and worse. And that way, that just symbolises that you've got a really bad problem with your system, and the design of the system and the setting up of the system, and they need to be addressed. And no matter what level of chemical you put on it, will never fix that.
Okay.
Not a power flush, not dosing, or this, that, and the other. They won't do anything because you've got a fundamental problem, causing an issue in your system.
Okay. So it's interesting how many conclusions you can draw from just the appearance of the heating water.
Mm-hmm.
Are there any other tangible tips on how I can quickly and easily find out how my heating system is going?
Yes. There is the smell of the water. You probably are familiar that there's you can literally do like your venting of a radiator. You can smell rotten eggs or something like that, or ammonia.
Yeah.
Things like that, which are, or even say they are byproducts of the microbiology that could be existing in the system or the corrosion processes. You may have seen videos on YouTube and so forth where people vent the system, air comes out and they put a match to it and it gives a whoosh. And that is basically methane, which is a byproduct of microbiology.
Okay.
So, I mean, there are other gases that can be created in the system. And also, using corrosion inhibitors will also discolour the water as well. But if it's a slightly funny colour, it's not so much a problem as long as it's clear.
Okay.
So again, it's like you're not creating solids and so forth. If you do create them, you've got to get rid of them. But that's another area altogether. But yeah, so you say the minor appearance, but does it smell? Is it flammable? Okay, might be not a great test, but yeah, is there a smell? Is quite a good indicator.
Okay, right.
There's some things going on.
That's the main one. Is it?
Yeah.
Is it a smell?
Yeah, rotten eggs or ammonia. Yeah.
Okay, thank you. We're now going to put a slide up on the screen for everybody to see. So the question I have for this, Steve, is I would have thought that the oxygen content would be a prime indicator. Why is that not included?
Well, that's
Can you talk us around the slide?
Yeah. Well, the first thing to note about the oxygen is, like we said at the start, it's relating to sealed systems. So you have the water in your system and it's isolated from the rest of the universe, effectively.
Yeah.
Once you take water out of the system to test it, you re-expose it to the universe and the physical laws reapply. So it will, if that water is short of anything, it will absorb it. So if you can see on the graph, there's a yellow line at the bottom. There's a horizontal line. Yeah, there's a horizontal line right across the bottom, and then another solid yellow line. It's on the one, yeah, a solid one on the left-hand side. That's about 7 or 8. So oxygen content of water that comes out of the tap is approximately 7.8 millilitres per litre of water.
Okay.
So when you put that in your system, you've got oxygen in that water. But what this shows is it measures in a sealed environment that oxygen level, and it measures that within 5 hours, all of that oxygen you've added by filling the system has reacted with any ferrous material and has been used up.
Okay.
So you have basically you've got to accept you're going to get some corrosion when you fill the system, because even if you manage to get rid of deoxygenated water, it's impossible to get out of anyway, as soon as you put it in the system, because the system isn't already full of water, it's full of air, some of that air is going to replenish the oxygen in that deoxygenated water, so it's a complete waste of time. You can't do it. So you basically have to say, right, we're going to have a bit of corrosion at the start, but it's a one-off. And we can predict from how much water we're putting in, how much corrosion we're going to get. And it's going to be spread around the system.
Okay.
But you accept that. It's a necessary evil. We're going to have that. But you say, once you've had that, provided you do all the other things to set up the system correctly, you shouldn't be having oxygen coming in. Therefore, you should be having ongoing corrosion. And then once you've got that, you'll still have gas/air problems in the system because you've still got nitrogen and so forth. You need to get rid of those. Yeah. Which those green lines on the graph, if that's still up and if you're interested. But that's what the deaerator or degassing solution will be looking at, is that green, the nitrogen and so forth, not the oxygen specific. They may get rid of some oxygen if it comes across it, but really, you think about the time it takes from filling the system to doing all the balancing and all this sort of thing, and then getting it circulating and heating up. That length of time probably is longer than it takes for the chemical reaction of the oxygen to occur. You're not really going to get rid of the oxygen. And to be honest, whatever you've got for removing air in your system is potentially in the wrong place if you do add additional oxygen through the fill-up water.
Okay, thanks for that, Steve.
Yeah.
So how would the different approaches of VDI and BS address an issue like this?
Well, if you think about the situation we're looking at there, is you've got a problem and an effect or symptom. So if I give you a comparison, imagine you were to hit yourself repeatedly over the head with a hammer. You'd get a headache, wouldn't you?
We think so, yes.
Which one's the problem and which one's the symptom?
Well, the symptom's a headache, the problem is hitting yourself on the head with a hammer.
Exactly. So from what I can sort of disseminate from the two different standards is that the British standard says, oh, right, okay, you've got a headache. Here's a tablet. And have a tablet every day for as long as you've got a headache. And all the time you're still banging your head on the head with a hammer. Whereas the VDI says, well, what can we do about this hammer? And then once you've dealt with the hammer and taken away the cause of the headache, you can then do something about the headache, whether that's deaeration, or these sort of things. But it's what VDI is one end of the process, and probably the BS is the other end.
Okay.
They're not fighting each other. One complements the other. Potentially, the VDI will minimise the requirement for what you do in terms of chemical because it provides good conditions and prevents the problems occurring that are associated with the chemical usage. They don't, they're not against each other.
Okay. So are you saying that decisions made during system design and installations can directly affect the level of corrosion the system will experience?
Very much so. Again, it's down to material choices, knowledge of the materials in your boiler and pumps and whatever like this. A very simple thing is, every time it used to be steel pipe or copper pipe systems, and then plastic pipes come alive. And nothing particularly wrong with plastic pipe, but there's two types of plastic pipe: one with an aluminium barrier core, one without. The barrier core is specifically there to prevent oxygen coming in. So if you're using a cheaper plastic pipe without a core member, you will always get oxygen coming through the walls. It's still watertight, but it's not airtight. Oxygen is a very small molecule that can pass through the walls and constantly re-enter the system. Okay. So little things like that, or even if you are using maybe a copper pipe system, but you're using speed fit connections, that's no way near as airtight as an old style soldered connection.
Of course.
So that's totally impervious. You may get air through a plastic component at a joint. You may get air ingress, which will oxygen ingress, which will obviously refuel the corrosion process, and that's what causes the perceived need for chemicals without understanding where that has come from.
Okay.
Yeah.
So corrosion is a major issue, and it seems very hard to eradicate this.
It's impossible. As I said, when you fill the system, you've got an empty space, but it's not empty, it's got air in it. Mm-hmm. And then you bring in the water to it, and you're going to make it create a need, especially with the ferrous materials, for that corrosion. But that corrosion, to an extent, is a necessary part of the process. You can't get rid of it, but you can minimise it and you can control it by good design, good selection of materials, and so forth, and obviously looking at what else you can learn from the system as it progresses through pH measurements, conductivity, and so forth, that you can understand a bit what's going on in the system, how to deal with those, and think, have I missed something? Like we saw on the slide, within a few hours, your free oxygen that you have available for corrosion has been used up. What you do have to be careful of is getting rid of too much ferrous. So if you ended up with just one small piece of steel in your boiler, for instance, and the rest of the system was all non-ferrous material and could not corrode, that oxygen that you filled up is a set amount and will provide a set amount of corrosion. Okay. But you've got one piece of unit of equipment or one component of a piece of equipment that will corrode. All that corrosion is going to happen at that one point. So it's not a good idea to try and get rid of all of it unless you can really get rid of all of it. Yeah. And I don't think anyone would be able to be able to truly do that. Could be wrong, there may be these in the future, but I think at the moment we're going to have to accept there is some ferrous, but we know what's going to happen with it.
And it's manageable.
And it's manageable. We can minimise it and control it. And the trick is you can't fill the system with water that's not going to have oxygen in it, because you need to fill the system to be able to balance it, set it all up. And of course, that water comes in, it's going to have that reaction, and the system's empty. It's going to absorb oxygen if you just put treated water in. So it's not, there's no way to just say no. We can get rid of corrosion. It just can't happen. There's too much chemistry and physics and everything behind it to allow that to happen. We're not that good as a race to be able to overcome those sort of problems.
Okay. So, what is the impact of the modern trend towards lower operating temperatures and the application of VDI2035 for cooling systems?
There's, say with air source heat pumps and things like that, underfloor heating, you do drop the operating temperature quite considerably. It's a swings and roundabouts situation. So if you think you're running a lower temperature, as we said earlier about your kettle at home, you'll get less limescale creation because the temperatures are lower. It's a win. But on the downside, you're going to have more problems with the microbiology.
Okay.
So it'll become these lower temperature systems that biocide control and application will become more important. Whereas maybe the limescale treatment, although it becomes less, it's less an issue, it's still going to be an issue because you're still heating up the water. But again, control of the water going in, either through softening or ion exchange and so forth, you're creating the best condition in the system to prevent a known problem. Again, are you going to completely eradicate it? But you are going to minimise and control it such that you're not going to have a sufficient issue that you're going to need high levels or continual amounts of chemical treatment. So it's all about making the best you can and then not having to touch it.
Okay.
That's any perfect system is one you don't have to go back to.
Yeah.
You don't want to go back to your heating system. It should be low maintenance. Anyone has to get a lot of maintenance every year, basically. You need a new system, not just a new component in the system. You probably need to think about the whole system.
The whole new system.
Yeah.
So thanks, Steve. Thanks for that. Appreciate it. Some good answers there. So that exhausts our frequently asked questions that we get asked on a daily basis about VDI 2035.
Yeah.
We've got a few questions in from the audience, Steve.
Right.
So I've got questions in from Pete. Thanks, Pete. Thanks for your question. So Pete says, VDI 2035 has been around since 2009.
Yeah.
Why have so many heating engineers in this country been so slow to adopt it?
Well, because they haven't had to.
Okay.
It's a very simple reason. As I said at the start, it's European norm, or more especially, it's a German norm. It's been talked about mainly because a lot of the boiler manufacturers are German, and therefore they, by extension, they do apply it and recommend it should be followed, and that just gets copied into the English version of the manual for the same boiler.
Okay.
But there's nothing to say it has to be used. However, hopefully I've sort of demonstrated that there are good points to it, and if you sort of take attention to it, it may be that you don't necessarily have to do it, but you can apply it well, and it will benefit your system, your installation, your reputation, your recommendation, your customer base, and all those benefits are to your benefit as an installer or such, or as a professional service provider. And obviously, if you're maybe on the FM side, you go, well, I've got a great system and it's going to work really well, and I've got minimal to do, and I haven't got to keep adding chemicals all the time, saving money, and not so much the money of buying the chemicals, but disposing of them. I think is going to become an increasingly high cost going forward with all this, all the environmental pressures and so forth that we have. So even though it's been around a long time, and we, by nature of the products we do, we've been aware of it, and we we sort of understand what it's going on about. There's no official need to do anything, but it's definitely a damn good idea to try and apply the ideas from it in the best possible way for the benefit of the market and the products and everything as a whole.
Okay, thanks, Steve. Thanks for that. And thanks, Pete. Thanks for your question. I hope that answers your question. We've got another question in from Alan. Thanks, Alan. Thanks very much for your question. So, Steve, Alan asks, some boiler manufacturers say that the system should be set up to British standards, while others are adopting VDI2035. Which do you recommend, and is the manufacturer's guarantee affected if I follow one or the other?
Obviously, I would say follow the manufacturer's guarantee.
Of course.
As I hope I've demonstrated, the VDI is more at the front end of what can we do to make the system as good as possible, and what can we monitor, and how can we be sure what's going on, and what can we adopt and apply to make sure we've got a good sealed system that we're not continually adding water to and so forth, that we haven't got air in, that we've got the right pressure. All these things added together will prevent the things that create the need for the chemicals at the back end. Rather than thinking of it linear, you think of it vertical, and you think of it like a pyramid.
Okay.
And every level of a pyramid is only as good as the level below it. Do you agree?
Of course.
Yeah. If you think about the bottom level is the water in the system. That's the baseline. You've got to make that as good as possible.
It's all about the quality of the water, Steve.
Totally. Saying that's with your pH, your conductivity, what it looks like, all these sort of things you can measure. Once you've got that water in the system, next level up, you've got to get everything in the correct pressure position to prevent air coming back into the system. Obviously, you've got to have a system that doesn't leak, so that then then you're not continually adding fresh water to it. So you put all in, then you get the pressure right. Because you've got the pressure right, you haven't got the air coming in. You therefore get rid of whatever gases you've got left, and the whole system runs more efficiently because you've got the water right, because you've got the pressure right, because you've got the aeration right. The corrosion is going to be severely limited. Therefore, whatever small amounts of debris and dirt that you've had, and magnetite and so forth, you will be able to get rid of them, and you're not continually regenerating them. So if you then you think you've satisfied all those four things, why do you really need chemicals? Okay, to satisfy the manufacturer, we'll put a bit in.
Okay.
But then when they say you must use an inhibitor, does it say in a proportion per litre? Well, I don't know. I've never read the guarantees in a boiler before. But it will say you should add inhibitor. It doesn't say by how much. So theoretically, you could set up a system quite well and put one drop of inhibitor in, and it matches the requirements of the boiler's guarantee. You say it's down to you to do your due diligence and understand these things. But what we're saying is that the VDI does not, by following it, will not invalidate a warranty that says follow BS 62. What number was it again?
BS 753. 7593.
7593. Yeah. Using VDI wouldn't invalidate it.
Okay.
But you say if you need to do something to meet the BS requirement, that's a requirement in this country, so you have to do it. But what we're saying is that adopting the VDI stuff will mean you don't have to do it as stringently. You don't have to pay attention.
So in summarise, you follow the manufacturer's recommendation.
But you can make definite improvements to attenuate the requirement to follow it to a great degree.
Excellent. Thanks, Dave.
And if you want to see a real world example of that, I could reference my home system.
Okay.
So I had a new boiler system installed 12 years ago. And when the guy came to service it last year, he remarked on how clean and clear the water was, and asked me how I obviously kept on top of the chemical dosing. And I said that, well, they put chemicals inhibitor in when I installed it 12 years ago. Oh yeah, I said, and that's it. I've never put any more in. And he was
never
like,
had any in 12 years.
Yeah, and he goes, but surely you need to top that up every year. This is really clean. If you just change the water. And I went, no, that's the water that went in 12 years ago. I think I've topped it up twice in 12 years, put a little bit into, the pressure was getting a bit low, and I've had the I had to replace the expansion vessel because that obviously died a death, so but you expect that to happen.
Yeah.
And he said, God, how are you doing this? This should all be corroded. It totally blew his mind. I went, oh, there's a deaerator and a dirt separator on the system. We're dealing. It was like, it's like it's complete madness. But yeah, you keep the right pressure. You monitor. I've got an ion exchanger on my incoming water, so I deal with the lime scale issue. I deal with the air issue. I've got the pressure issue under control. I get rid of the dirt. All those things together. I don't need to add chemicals because the guy went, bloody hell, this water's really clean. It's the cleanest system I've ever seen. And then he did the efficiency test. And for a 12-year-old boiler, it came back at 98%.
Wow.
And he was like, oh my God, this is amazing.
Wow.
So, all the things in VDI work. You've got to apply everything properly. And if you apply all those things properly, your need for chemicals is reduced. Simple as that.
When you get a system like yours.
Yeah.
Cheers, Alan. Thanks for your question. I hope that answers your question, Alan. I think we're just going to check to see if we've got any more questions.
Yep, there's a question from Scott in the chat.
Hi, Scott. Thanks for your question.
I think you touched on it slightly in your last answer. It's VDI2035 is clearly the way forward. However, the Part L regs are changing this June and saying that we must follow British standards and use inhibitors, etc. With this change, how are we able to use VDI2035?
Again, you can look at what it covers. It's got very different terminology. Apart from the title, which seems to imply they are similar things, achieving similar things, they're not. It's like one's at one end of the spectrum, one's at the other, and by following one, you would limit the need. So yeah, use chemicals by all means, but if you've set up a system where you need to use the smallest amount possible, great. And then when you go back to test it, I think the British standard says you should at least every 5 years replace the re-add inhibitor. But as I've proven, 12 years, no problem. Yes, you need to add inhibitor. Do you need to add half a litre? Do you need to add 1 drop? That you can only tell that from testing your pH, your conductivity, so on and so forth. So it may take, means you need to do a little bit more testing. But to me, that looks more professional. Yeah. If someone comes along and says, I'll do a test of this, and this is your pH value, and they give him a white coat. He's a bloody doctor, So maybe you could take these on board to, provide a more, professional service, a more educational service alongside the service you're actually providing. I hope that was...
Yeah, thanks, Dave. I hope that answers your question. Do we have any more questions at the moment?
I think that's it for now, unless someone has any more.
No, we don't seem to have any more questions coming through, but we've had a few. We've had some good questions, so some excellent answers there, Steve, so thank you very much.
No problem.
So, yeah, that concludes our discussion on VDI 2035 for today. I'd like to thank you all for joining. I hope you found it all beneficial. Okay. The next web chat we're going to do is going to be on the 11th of April, where we're going to be discussing pressurization. Sorry, not on the 11th, it's on the 20th, correction. So the next one is on the 20th of April, where we're going to be discussing pressurization. So I hope you can join us for that. So again, many thanks for joining us, and I hope you find it all beneficial, and thank you very much, Steve, some excellent answers there.
No problem.
Appreciate it. Thank you. Thank you very much.